every serious AI model is trained to say no. Ask it for something dangerous, and it refuses. But researchers have found ways to surgically strip that safety away. This paper asks a sharp question. Of the two main methods for doing it, which one leaves you with a genuinely more dangerous AI? There are two ways to remove a model's guardrails. The first is jailbreak-tuning. You slip a few harmful examples into otherwise benign training data. The second is weight orthogonalization. Instead of retraining, you find the one internal direction the model uses to refuse, and you delete its ability to point that way. That second method is worth pausing on. Models seem to route their refusals through roughly a single direction in their internal activations. Weight orthogonalization estimates that refusal direction, then edits every layer's weights so the model can never write to it again. No refusal direction, no refusal. Jailbreak-tuning has a scary track record. Just a 2% dose of malicious data, it has slipped past OpenAI's moderation to fine-tune GPT-4o, cutting that model's ability to refuse by as much as 96%. Both methods are known to make models comply, but past work only measured whether the model still refuses. Nobody had asked the scarier question. Once the guardrails are down, which method leaves a model that is actually more capable of causing harm? So the author unaligns 6 popular models, 3 standard instruction models, and 3 reasoning versions with both methods. Then puts them through a gauntlet. Do they still refuse? Can they craft attacks on other AIs? Can they aid cyber attacks? Do they hallucinate? And are they still generally smart? First, refusals. As expected, both methods gut them. Weight orthogonalization cuts refusals by about 74% on standard models, jailbreak-tuning by about 62%. It's basically a tie. Each method wins on half the models. But a model that stops refusing isn't automatically dangerous. The real test is whether it can act. Now the divergence begins. When these unaligned models are turned into attackers against other AIs, the orthogonalized ones are far more effective, crafting on average 28% more successful attacks. For reasoning models, 40% more. The jailbreak-tuned models were wildly inconsistent, sometimes worse at attacking than the untouched original. You can see it here. The yellow bars, the orthogonalized models, tower over the red jailbreak-tuned ones across almost every target. And the blue bars are the fix we'll get to in a moment. The story repeats for cyber attacks, tested on 1,000 real-world attack scenarios. The orthogonalized models got better at aiding cyber attacks across every single model. The jailbreak-tuned ones, for half of them, poisoning the training data actually made them worse at it. Why is jailbreak-tuning so inconsistent? Because it damages the model. Jailbreak-tuned models hallucinate dramatically more, up to 41 extra points on a summarization test. The orthogonalized models barely change, and in half the cases actually hallucinate less. And on raw intelligence, the gap is stark. Jailbreak-tuning drops general helpfulness by over 13%. Weight orthogonalization, just over 2%, a 6-fold smaller hit. The surgical method keeps the model sharp. So here's the uncomfortable verdict. Jailbreak-tuning gives you a compliant but lobotomized model, willing but clumsy and unreliable. Weight orthogonalization is the truly dangerous one. It removes the conscience while leaving the intelligence fully intact. But the paper ends on a hopeful note. The dangerous, orthogonalized models can be repaired with nothing more than ordinary fine-tuning on benign, helpful data. This restores refusals in every case and cuts their attackability by about 45%, without making them dumber or more prone to hallucination. This figure sums it up. Orthogonalization, the yellow bars, barely raises hallucination or lowers helpfulness, which is exactly what makes it dangerous. And the fine-tuning fix in blue pulls the harm back down. There's one catch that keeps this from being a solved problem. Weight orthogonalization needs white box access to the model's weights. Jailbreak-tuning can be done through a public fine-tuning interface by data poisoning, and has already slipped past commercial moderation systems. This isn't hypothetical. The paper points to real incidents where frontier models like Claude were jailbroken and used to help run large-scale cyber campaigns. Safety training is a barrier to entry for bad actors, and unalignment tears that barrier down. The takeaway for AI safety is twofold. The scariest attack isn't the one that makes a model comply, it's the one that keeps it competent while doing so. Defenders now have a concrete tool, benign fine-tuning to blunt it. The one-line takeaway. The most dangerous way to break an AI's safety is the one that leaves it just as smart. And the good news is that simple fine-tuning can heal it. If you enjoyed this, there's a new paper decoded every week, and you can suggest one in the description.